Yeah, hi, good morning. I'm audible team.
Yes, Veera. Veera, can you
I
wait
think,
for two
yeah,
minutes?
sure. Yeah, sure. Okay, shall I
Oh,
proceed?
yeah, you can proceed. Veera.
Yeah, let me share my screen. So yesterday we have discussed on Kubernetes very high level concept. What is worker node and a control plane? How the request will go to first control plane and then control plane is assign the task to worker node to kubelet component. So actually, guys, in the Kubernetes, as I discussed yesterday, so we can work with EKS or AKS and GKE. Okay. So first we need to understand, we are going to understand AWS EKS means AWS Elastic Kubernetes Service. So 99% projects are only cloud manager Kubernetes only, not in on-premises managed Kubernetes. That is very difficult to manage, so that all companies are migrated to cloud manager Kubernetes service, either AWS EKS or AKS or GKE. So let's understand what is AWS EKS first. So as we discussed yesterday, the node, let's understand very high level now. For example, this is control node. So these are worker nodes. Worker node 1, here worker node 2. Okay. So this control node, if it is AWS managed means this is taken care by AWS only. So even if you can create a AWS EKS Kubernetes service, we are unable to see this control node. This is completely managed by AWS. Managed by AWS. So worker node is actual our pods deployments, our application deployments are we can deploy in worker nodes only, not control node. So pods we can deploy in worker nodes, not in control nodes. So here also pod. Yeah. So this control node is taken care by these pods. But now the important thing, So we need to execute the Kubernetes commands, right? To execute the Kubernetes commands, we need some environment. So whenever I execute these commands, I mean client EC2 or laptop, this is EC2 or laptop. So these instructions will go to control node. So whatever commands you are giving here, kubectl apply and something, whatever. So the request will go to, through this environment, the request will go to control node, like a Docker daemon. If you run any commands, the request will go to Docker daemon. The Docker controller is taking care, right? Same thing, kubectl apply. If you run here, the request will go to here, control node. So this control node, as per this request, it will start the process to initiate the pods into the worker nodes. So this is the process. Now the creation of the process of AWS EKS, the Cloud Manager Kubernetes. So we have to follow some process here to deploy. Let's go to my document here. So this is the concept what we discussed. Kubernetes is a container orchestration system that was initially designed by Google and helped to scale the containerization application in the cloud. Now, a Kubernetes cluster is composed of two separate planes. One is control plane and other is worker node. So control plane is organized the worker nodes and everything. And the master node components and control node components are yesterday we discussed, right? These are. And a very important thing now, we are going to discuss core components. And you just ignore the mini cube concept, not required. And now if you can come here. So to create a EKS cluster, this is the command. Sorry, this is the command. EKSCTL create a cluster name region node. So if I want to execute this cluster, either my laptop or EC2 instance, the request will go to AWS EKS. So the EKS will be initiates the process to create a cluster. But here to run EKSCTL in your server or laptop, first you need to install EKSCTL. Once cluster is created, you need to be interact with your cluster by using kubectl command. All commands interact through kubectl only, like a Docker commands, Docker, how like same like kubectl. So in this case, first you need to install kubectl libraries. So kubectl is a Kubernetes specific command line tool that lets you communicate the control Kubernetes cluster. I mean, whatever the kubectl, if you run this is interact to control plane. I mean, your interaction from your server to control plane by using kubectl command only after create a cluster. So you need to be installed here. The prerequisites are what? One is kubectl and EKSCTL. So cluster we can create by using EKSCTL. So we need to install these two dependencies first. Okay, let's start the process. Now, let me launch. Uh, So I'm creating a one server North Virginia region to interact to create a cluster. To run a CLI command, EKSCTL create a cluster is a CLI command to create a Kubernetes. If you want to execute the CLI command, we need an environment, right? By either laptop or EC2 server. I'm taking EC2 server only. Environment to interact EKS. Launch server. Okay. So we can create a EKS cluster. Cluster is nothing but combination of worker node and control node. We can create a EKS cluster by using CLI command, by using manual process, by using Terraform. So now this process is CLI process. I'm going to execute the CLI command to create a cluster, EKS cluster. Okay. Why I'm using CLI command? So control, we will get a more control. Create a cluster, just simply one command we can give, it will be created. And while deleting time, simply we can run a delete command, so we can delete a cluster. If you create a manual process, the configurations maybe if manual configurations maybe need to take 20 or 30. It's very difficult to destroy. So whenever you can run single command, it will be create single command, we can destroy it. But in real time, so we have to specify each and value for the cluster, the security groups and all. Now, whenever I can give a EKS cluster create command, default actions will be created the background, default subnet, default VPC, default SG group. But we have to define these all configurations in custom way, so that we have to create through using by using Terraform only. Okay. Um, First, before that, I'm interacting from here to my control plane, right? So first, let me create a, let me know the water prerequisites are there. First, we need to install those. So the prerequisites are here, EKCTL, kubectl. So the first step, what you need to take care here, uh, create EKS, download EKCTL. Just you can go here, EKCTL dependencies packages. You can take from Google also, no problem. Okay, and then just move to user local bin to execute EKSCTL version, to execute the EKSCTL in bin level. So now you can give EKSCTL version. So this is done. EKSCTL is working fine. Same now kubectl. After creating cluster, you need to interact by using kubectl command. This is kubectl dependencies. And next, I'm giving executive permission for this kubectl. And then move it into here. Now kubectl version. Okay, I'm able to see kubectl version also. Let's create a cluster by using CLI command. So, and very important thing is my EC2. So you are running CLI command here to run EKS cluster. So first your this EC2 instance should connect to, I mean, should communicate to AWS EKS service. See EKS service. So this is AWS EKS Kubernetes service. You can add a cluster. So create a cluster. You just give a name and give select role and version and all points you can give and create it. Or you can create this cluster by using CLI command. So as we discussed in the previous classes, we have a different approaches to communicate to create a AWS resources. One is Terraform, one is console, one is CLI. So to create a EKS cluster from this EC2 instance, first your EC2 should be permission required to create a EKS cluster. So that we need to create a AM role to talk to communicate EKS cluster, your EC2 instance should be communicate with EKS cluster, and it is able to create a EKS cluster. So now you can give admin access or whatever access. So my end already permissions already there. Let's go here. So this is my server. I'll just give a, I will attach IAM action security, modify IAM role. So I'm going to give a existing IAM role EC2 admin or EC2 EKS. This role already created. I have given administrator permissions for my EC2 instance. So my EC2 is able to talk to any service in AWS now. So now the first we need to talk EKS only. So the command is here. Either you can give full access or you need to give these many access for your role. IAM, EC2, VPC, cloud formation. These permissions are required to create a EKS cluster for your EC2 instance, or you can give admin access. So create your cluster and nodes. This is the command EKSCTL create a cluster, cluster name, region name, node type, size of the node, and how many nodes, minimum, maximum, which availability zone. This is basic command. So, and otherwise you can give an example here. If you can create like this. So, if you're not specify any node size, minimum worker node size, by default, it will take 2 nodes only. And zones also, if you're not specify, it will create instances, any one of the zone inside this AP South one availability zone. So I'm creating now. So Mumbai region, I'm creating a, from the North Virginia region, I'm creating a Mumbai EKS cluster. This is just environment, CLI environment to run a CLI command. You can create from your laptop also, EKS cluster. So same command you can execute here, VS Code also. So from here, you need to configure access key secret key. So this your cluster is able to create from here VS Code also. Same process. So here you need to install EKCTL, kubectl. From here also we can interact. The Terraform we have installed, right? So here we need to understand very important thing, guys. Try to understand here. So whenever you can execute the CLI command, the background, the AWS will create a EKS cluster with help of cloud formation template. So what is cloud formation template here? So cloud formation template is like a Terraform, but this is not third-party tool. This is AWS Terraform. Just understand this is AWS Terraform. Okay, not Virginia. It is in Mumbai. This is AWS native service. The cluster is creating in progress, but I'm not creating this cluster through CloudFormation template. I'm creating through CLI. Even you can execute the CLI command, the request will reach to CloudFormation. CloudFormation will create a EKS cluster by defining all default actions. The reason you haven't specified which subnet, which VPC you haven't specified, right? So that this cluster will be created in default VPC, default subnet, default SDs and all. So CloudFormation template is a service AWS is offers. So if you can go here, resources, these many resources are going to create for the cluster, VPCs, subnets, service role, route table, NAT gateway. These many services are required to run a one cluster. So these many I'm not passing from through CLI. Just I'm giving create a cluster through CLI. So the cloud formation will take these options by default options inside the Mumbai default VPC, default subnet, default internet gateway, and everything it will be configured. 24 resources. So after some time, we can see my cluster got created so that we can interact with your cluster now. See, cluster is nothing but here control node and worker node, but we are able to see only worker node. So Mumbai region, if I go, I'm creating a cluster in Mumbai region. If I go, 2 nodes will be created. The 2 nodes is worker nodes. We are unable to see control node, but If you run any command from here, the request will go to control node managed by AWS. From there to, it will come back to worker node. So now this is my EC2 instance where I'm running CLI command. So request will go to control node AWS manage. From here to here, the worker nodes will be created. This is the source to interact control node. So these are worker nodes managed by control node. But control node is not managed by this environment. Just we are giving we are giving user is interacted. User is interacted control node by using this instance environment. To run Kubernetes commands, we run here. This will go to control node. Whenever you can create a cluster from any server or any laptop, so this control node related information will be stored in this instance. So that instance will be communicated control node. I will show you that also. So that file is .cube file. So this .cube file will be updated inside the EC2 instance. This .cube file is updated control node configuration so that your instance is able to control node. So by default cluster, whenever creating a cluster, this interaction will come control node to worker node. No need to create any configurations. So whatever yesterday we discussed, just for understanding purpose only, how the request will go, how to manage and all. But here no need to configure any components. Everything is managed by cluster only. Here we need to focus our deployments. So clear or any doubts? So it will take some time, 15 minutes of time to create a cluster, 15 to 20 minutes of time. And meanwhile, we can go to Mumbai. Cluster is creating progress. So you can open EKS here, AWS EKS, what I'm creating by using CLI. We can see cluster is creating progress here, also see creating mode now. Okay. Do you have any questions? Meanwhile, it is taking time to create a cluster. Please clear your, I know if you are having any questions, please clear now.
Amazing.
Hello.
Yeah, yeah.
Yeah. Vira, where are the places we can exactly see this in EKS cluster and CloudFormation stack, right? Only these two are the places, or is there any other places?
Sorry, your voice is breaking. Can you please repeat?
Oh, sorry, Vira. Is it clear now?
Yeah, yeah.
Yeah. Are these the two places, EKS clusters and CloudFormation stack, are the only two places we can see this cluster, or are there any other places?
Yeah, actually, we are creating cluster by using CLI. But CLI, whenever you run a CLI command, that command will initiate the CloudFormation template to create a cluster. The background process, no need to verify this even. Simply run a CLI command to create a cluster. We can come on here. We can see here. This is the dashboard of EKS, like EC2 instance, like S3. But just I'm showing you here how the request will come through CloudFormation template to EKS cluster. This is no need to verify even. Just for your understanding purpose only, whenever I can execute a command here, the request will go to CloudFormation template. CloudFormation template is an infrastructure as a code, like a Terraform, but this is AWS native service. So whenever you can execute the command, this will go to this will go to CloudFormation template, and CloudFormation template will initiate the process for creating a cluster. The background taken care. No need to do anything by your end, the CloudFormation configurations. So we can usually we can use EKS creation by using Terraform. The Terraform is taking care of everything. This is just a CLI method.
Got it.
Yeah, I will show you through EKS also, through Terraform also. Sorry.
Okay.
Let's check here. Not North Virginia, it is Mumbai. Refresh here. Cluster is in active mode. So go to Mumbai. Cluster is in active mode. So we can discuss later. You can just have it look on this after this compute node group networking and all. Okay. Let's go to let's Mumbai. You can go to click on EC2 instance. Okay, see worker nodes already created. Test is name, ng means node group. Node has created node 1, node 2. So now if you can see node 1, node 2 created by using control node. We have given instruction to control node. I mean, we have instruction, we have created a cluster by using CLI command. So this entire cluster, we can see only worker nodes. The reason this is AWS managed, just a minute, guys, please. Yeah, sorry guys. So if you can see, we can understand one by one now. Okay. So first worker nodes are updated. These worker nodes are main nodes where we can deploy our pods. I mean, sorry, where we can create a pods and deploy our applications. So the worker node is nothing but EC2 instance only. But these two worker nodes instructions are coming from AWS. We are giving instructions to AWS from this instance. Now kubectl commands, all Kubernetes commands start with kubectl. Kubectl get nodes. This request will go to okay. Whenever you can execute this command inside this server, so this will go to control node from here to here. It will give the worker nodes information API server will give to you. Okay. Now let's go to understand cd.kube ls vi config. So whenever you can create a cluster, this cluster authentication, authority, and the role, the Mumbai related, you have created through Mumbai region, right? See, cluster name and the name and here context. So these are related to permissions. Okay, EKS cluster is related information. Everything is updated inside the dot cube. So this dot cube is updated your this server where we can run a CLI command. Now, what we can understand, this dot cube is not there for every server. If you go for any server, this dot cube is not there for every server. From this server only, I have created a EKS cluster so that dot cube is updated here, this cluster inside this ESOT instance only. Now, this instance, that's what able to access my EKS cluster. I mean, especially control node. Whenever kubectl will get nodes, I can give here. Whenever I can give kubectl or kubectl get nodes. So I'm able to get the information from worker node. Your instance, first of all, your instance is able to communicate. Guys, this is not a control node. One second, I'm saying that. This is environment to connect your control node. This is not a control node. We're unable to see control node even. Okay. So this request, it will go to worker node only whenever you can give through control node. Control node managed by AWS. Okay. So this is the main process, the creation of cluster and all commands and all. So now we need to understand very important thing now. kubectl get nodes, kubectl get pods. These are the commands. So Kubernetes commands are very easy. We can easily remember. We can easily, understand also even. So now what we can understand from this now. So now let me. So Kubernetes is nothing but what orchestration tool of containers, right? So now whenever you can create a Kubernetes, whenever you can create a pod by using Kubernetes cluster. So we can see the running pods, what kind of application is there inside. We can verify each and everything. So you need to understand till push your image to ECR, we learn, right? Now Kubernetes source is ECR image or Docker private registry image or wherever you can store your image. So, and Kubernetes will support only AML language. Excuse me. So Kubernetes is developed by Google. Just one second, I'm just confirming that. And Kubernetes supports only AML language here, so that you can write a AML language here to understand whatever deployment and everything. We can write a AML language only here. So we can see the basic AML for to create a pod inside the Kubernetes. Okay. So let's go to, and this is the Kubernetes official registry. You can Kubernetes, you just give a pod, sample pod YAML. So this is kubernetes.io is the official registry. So we can find out all the pods information and all here, how to create a pod by using this YAML file and all. So the interaction of the cluster, everything by using YAML file only, the whatever deployment or deployment and service, whatever you are going to create. So first of all, we can understand what is pod. Pods are smallest deployable unit of computing that you can create a manage in Kubernetes. It's like a smallest deployable unit. It means it's like a kind of server only. So we can deploy our application inside the pod. So pod will support one or more containers even, but in real time we are using only one container. So once again, the pod is set of pods that run a single container, whatever more information if you want to learn, just understand. So pod is nothing but a just deployable it's created environment deployable environment, so that smallest unit here is very lightweight like a container. So as we discuss here, the very important understanding, let me take a pod creation YAML file. So yeah, this is my pod.yaml, guys. The creation of pod here. So how to understand this YAML file? The first one is API version is common for any YAML. I mean, the coming lectures we are going to discuss deployment.yaml, service.yaml, whatever horizontal pod autoscaling.yaml. So if you can take any YAML, API version is common. This API version is useful to interact your API server. And next is kind is what here? Pod. Kind is what here? Pod. And First entry is version. Second entry is kind. Which deployment it is? Pod deployment. Okay. And this is metadata information for name of your pod. Name of your pod. And then finally, the specification of this pod. This is the image I'm creating. Sorry, this is the image I'm creating. I mean, this is the container I'm creating from this image. So, and we are giving a port block where exactly the container is running. Your application will be run. Nginx always port number is 80, right? So Nginx default port number is 80. So that's what we are giving 80 here. So now this image is a public image. So whenever you can execute this YAML file, the first Docker will run the container. Before that, Docker will pull the image and start the container and run the container and create a pod. This is the process. And here, let me understand here this concept. Okay, this is pod. If you understand what I'm going to create now. Okay, this is pod, what I'm going to create now. And now inside pod, the next layer is what? Container layer. So this container created from inside container, we have a application. Okay, so this application has deployed inside the container, and the container will create along with that application with the help of what? Image. So image, from the image, application and container will be created, and after that we have a layer pod. So in this case here, image block, my image is what here? Nginx. So this Nginx always runs on port number 80. Okay, now our understanding is here. So this is container port, this is image and the name of the container, and this is pod. That's what pod YAML looks like. If you can see, these many instructions are required to create a pod. Image required, container name required, port number required, name of the pod required, and kind is required, API version is required. This is the YAML file need to be understand here. And so let's go to my interaction, my environment here. So here I'm going to create a one pod. So you can give name of the pod, extension should be YAML, give the name anything, pod.yaml or anything YAML, but extension should be .yaml. So I'm giving here paste this YAML file. So this is very important, easy process to understand YAML file, YAML language. The first is API version, I'm giving v1. And next is kind, I'm giving pod here. And next is metadata. So metadata inside we are mentioning like a labels. We'll discuss what is labels, and we can give name and labels. Name is nothing but pod name. So this name comes under metadata. That's what you have to give two tabs, space and write a name. This name comes under metadata. Okay, that's what. And next again one more main entry, root entry. I mean parent entry is a specification. This is parallel to all. This is independent entry. Inside specifications, container information will come. So inside container information, see if you're writing inside means we have to give a two tab space, 1, 2, and right here. Now container inside name, the name of the container you're writing 1, 2, name. And inside container image also comes. So port also comes. These are comes under parallel entries. Inside port, we are writing container port, 2 entries and writing a container port. Like this, we need to understand the AML file, AML language. For example, the left key name should be like a different color, blue color, and values should be white color. So if you create like this is AML. The configuration issues will come. The reason here, the container port, you have to give space here. So key name should be different color, value should be different color. If you like this, if you create like this, indentation issue will come. So it is unable to create your AML file. Okay, I'm creating a pod. What is the image? What image you are using? Nginx image only. kubectl. The command has to create a pod. You have to use kubectl apply hyphen give the pod.yaml. If you run this command, one pod will be created. The pod inside Nginx application will run. The reason I'm taking Nginx image. So if I apply now, you will get a better clarity now. So my pod Nginx has created. Now how to check the created pod? So now you can run kubectl get pods. See, my pod is running ready state one by one. Started state, running state. So this is second one. One is creating state. First one is running state. So both are in up and running. Your container pod is up and running now. So now if I want to know more information about this pod, like a Docker inspect command, here we have if you want to know more information about container, we have to run Docker inspect container ID. So here Docker inspect pod, give the pod name. This is the command if you want to inspect more information. Sorry, wrong command I have given. Not inspect, describe. Sorry, this is Kubernetes, right? We have to give kubectl on always. Yeah, if you can see now, so these are the information about your pod. So I ran this command here. Now if you can see your pod IP, status, your node, where exactly your pod is running, on which node this pod is running, and the container ID of the pod, inside pod container ID, state of the container is running. Okay. So container ready state true, ready state, initialized state, these are conditions are true. And pod volumes, we'll discuss later. These are pod volumes information. And this is the events, how events will be generated whenever you can run a kubectl apply -pod.yaml. So if you can see, the process is started from here. The first process is scheduled. So your scheduler is schedule the pod assign to this node. Now node is ready. So the next step is pull the image. Pulling image from where? Nginx Docker Hub registry. And after that, pulled image, successfully pull the image. And after that, create a container Nginx, creating a container. After that, started a container. These many actions perform the background. So Nginx image pull from the Docker Hub registry if it is not there in the local. After the start, create and start the container. So the API will give the request to scheduler. Scheduler will give back to, okay, we can create a pod in this node and immediately start the process, your kubelet, run the container runtime. So pull the image and successfully pull the image, then run the container runtime, start the container and give back to API. So created a container. So now again, if you can see kubectl get pods. If you want to understand your pod is running on which node, so simply you can give kubectl describe pod. We can verify the node where exactly the pod is running, or you can give -o wide command. If you give, you can see the more information. So running pod on which node and pod IP and everything we can see here. Okay. So this is the process to create a pod inside Kubernetes. Now this is single pod only. It is not a orchestration, just creating a pod. Orchestration is nothing but if your application is taking more traffic, automatically Kubernetes has to be run one more pod. But if you understand one thing, this is simply pod only. There is no any replicas. If I delete a pod, one more pod will not be created. The reason this YAML file is to create a single pod only. So this is not recommended to run in real time. This is for just understanding process, what is pod and all only we are creating. But real time we are creating deployment.yaml file. In the deployment.yaml file, additional entry is there, replicas entry. So that whenever you can apply deployment.yaml, we can see number of replicas also. One more can, I mean, instead of running one container, 3-4 containers will be created as per the replicas. Till here clear or any questions?
Veera?
Yeah.
Yeah, in the YAML file, we are providing all the details, right? Can we provide the node details also or specify the node?
Good question, but not now. We'll see. That's what
Okay.
we discussed, right? We have to provide the node details also, where exactly scheduler has to create a pod on which node. It's a user defined. If you define, scheduler will follow. Otherwise, scheduler will follow default actions.
Okay.
It's clear, Veera.
Yeah. What about others?
It's clear, Veera.
Okay.
Clear, Veera.
Okay. Thanks. Yeah. So the problem is, if I create a pod, we are not getting any high availability. The reason simple. Kubectl. These are commands only. You just need to be practice. If you want to delete this pod, kubectl delete pod nginx pod name. If I give like this, pod will be deleted. Now, if I check again kubectl get pods, no pod will be created immediately. The reason this is pod.yaml only. There is no any replica entries are here. So to work on this, to get a high availability, simply we can go for. So simply we can go for, if we can go for worker node components. Excuse me. So if you go for this concept, see pod.yaml we have already created, right? So we need to go for replica set.yaml. So this is replica set.yaml, guys. Creating now replica set.yaml here. I will explain the YAML file also here. Replica set.yaml. Paste. Okay. So now same like this is like also pod only. Let me compare here. Simply we'll get a better clarity. Yeah. Okay. This is replica set.yaml. What is replica set? So replica set, we have an advantage here. If you use the replica set.yaml, this is the advantage. So 3 pods will be created immediately. These 3 pods always exist at all times. One more, if any pod will be created, immediately one more pod will be created. Means maintain 3 pods, 3 copies, 3 replicas always. If you create application through replica set, if you create application through pod, only one copy will come. If it is deleted, no high availability concept will come. But if you create a application through replica set, you will get high availability concept here. And let's understand our process from the scratch. So the first entry is same like a pod API version. But API version is pod is only V1. Here apps V1. For replica set version is different. Here kind is pod. Here kind is replica set. Here metadata. So name of the pod Nginx. Under metadata, name of the replica set is WebRS. And after metadata, we have a spec. Here pod specifications is container and image. A replica set specification is here. So replica set own specification provide a replicas. Okay. And then selector match labels. These are new entry. Okay. Let's understand selector match labels app web app. Labels are means what? So replica set labels are app web app. So where we can use the labels, I will tell you. Just wait. So now if you can see, this is the entire block. If you can see, this is which is equal to pod. If you can see this entire block. Okay. This template block, if you can see, this is entire pod only. You can compare with this. So here replica set plus pod is equal to replica set. I mean, sorry, replicas plus pod is equal to replica set. That's it only. This is pod. On top of the pod, if you add on top of the pod, so remove this version and pod metadata. So on configuration, spec configuration of pod, if you add a replicas, it is also replica set only. Okay, this is pod. But the condition is very important here. We need to follow. So each deployment, I mean each YAML file, there is a own labels. The labels are very important, very powerful here. To communicate your replica set to pod, we are implementing labels here. So here, if you can see this, replicas are 3 pods should exit all time. Selector pod label should be defined in replica set label selector. I mean, in this replica set label selector, we are defining pod labels. Okay, so otherwise it is not going to run. This label both match. This is pod, right? Pod label should match with replica set label. Otherwise, replica set will not be created. Okay. In the replica set entries, we have a labels. Labels comes under specifications here. Selector under selector specifications, the pods, the replica set labels will be defined here. So we have to define these labels as per the pod labels only. So now if you can give like this only, your replica set is able to connect the pod and create a multiple pods. See here, at least one pod label should match with replica set label selector. My replica set label selector is app web app. My pod label selector is app web app and type front end. These are 2 labels. At least one label should be matched. So labels are here 2. Under labels, here 2 labels are there. One is app web app. One key name and value is a web app. This is one label. Second label is type equal to front end. So you can use any one of the label here, replica set, so that replica set is able to connect with pod, link with pod and create a multiple pods. So pod label should be defined in replica set label selector. At least one pod label should be matched with replica set selector. Understand, this is very important. And this is enter pod YAML only. No need to explain here. Okay. So how to apply kubectl? Apply -f. Okay, let me give here vi replica set. So here my pod labels are here. Sorry, my replica set labels are here. My pod labels are here. So my pod labels app, web app or type front end. Any one label I can use here. For example, insert. If I use different label in the replica set or pods, I'm adding different one more piece. So labels are mismatched. Let me create now kubectl apply -f my replica set.aml. See, the replica set WebRS, the name of the replica set is invalid spec template metadata labels, invalid metadata labels, invalid values, map string, app, web app, type front end. So selector does not match the template labels. So these are the pod labels, app, web app, type front end. This is does not match with your replica select label. That's what it is unable to create. Again, if you go here, insert, I'm giving web app only now, removing one P. So both labels are matched. So pod label, replica set selector label, both should be matched. So that only at least one label should match. Now you can apply. So this time replica set has created. Now you can check kubectl get pods. 3 pods are running. The reason the 3 pods are running, the reason my replica set replicas are 3. So my Nginx applications are running in 3 pods. If you can give O wide, I can see the pods are running which nodes also. So scheduler by default is schedule the pods. See, 2 pods are running one node, 2 pods are running different node. See, different node. Okay. Now, yeah. So kubectl get RS. RS means created replica set. I'm going to check my created replica set. If you can see replica set RS we can give. So my kubectl get replica set if I can give, this is the replica set name. Desired state is 3, current state is 3, ready state is 3, age is 15 seconds. So whenever now kubectl delete pod, I'm going to delete a one pod. Any one of the pod you can delete. Okay. Now desired state is 3, but current state is now 2 only. Once whenever I delete. Now again check kubectl get pod. See, 9 seconds ago, one more pod has created immediately. So maintain the current state is equal to, sorry, desired state is equal to current state. So here one component will come into the picture, controller component. Yesterday we discussed, right? Kubernetes, we have a controller, any pod will be deleted that will notify through API. Immediately controller will run the replica set.aml to maintain one more pod here, to maintain desired state is equal to current state. This is called self-healing. So always maintain 3 pods. That's it only. Whether load is there, whether load is not there. Always maintain 3 pods. This is replica set.aml. So here we have a different approaches. Deploy application through replica set, deploy application through application means Nginx here. So you can give your own application. Means already we push our images into ECR, right? You can give that application also here. So now, okay, my three pods are running with the same application, but 2 pods are running one node, 1 pod is running one node. Even node also deleted, no problem. Still at least 1 pod is running in different node. So we'll get high availability. So this is called self-healing concept. And we have a one more YAML file, that is deployment.yaml file. So now let me delete this first, kubectl. So if you delete a pod will be created again. So that's what we need to create a directly replica set. Delete a replica set. Kubectl delete rs. My replica set name is what? WebRS. So deleted If it is a pod, kubectl delete pod, pod name. This is the replica set, kubectl delete replica set name. Like that you need to manage. Okay. Now kubectl get rs, no resource will found. The reason I have deleted replica set. Kubectl get pods, pods also will be deleted. Replica set controller you have deleted, right? So nothing is there. So this is replica set concept. We have a last concept is deployment.yaml. So worker node components, we have a 3 type of worker node components to deploy your application by using pod.yaml, by using replica set.yaml, by using deployment.yaml. This is last one. See the replica set and deployment.yaml only change kind. Everything is same. Just change in the replica set in place of replica set, change the deployment. That's it only. So deployment.yaml will be created. Then what is the advantage? We'll discuss now. So vi deploy.yaml. Insert. Okay. So kubectl apply -f deploy.yaml. Same deployment.yaml also. Deployment.yaml also give the replicas entry. Same like a replica set. See, there is no difference. Only difference is kind. Remaining are same. Then what is advantage? Then you can run replica set.yaml, right? Then why you are creating deployment.yaml here? The reason we have a few advantages if you run deployment.yaml. The advantage, the main advantage, main benefits are, for example, guys, for example, 3 pods are running. Okay. Now my image in Nginx is a public image, no problem. But if I'm using a private image, I mean, developed by developers or we are developing application, whatever. That application already deployed. That application is running in 3 pods. Now developers push the changes into GitHub. Again, we need to run a Docker file. Again, one more image will be created. If you change the image here, the deployment.yaml. So if I run 3 will be deleted immediately, 3 will be created immediately. So image old pods will be deleted, new pods will be created with the new changes. If I change image. So what I'm trying to say here, va deploy.yaml. So here I'm using Nginx 1.14.2 version, right? Let me delete using only Nginx. It will take latest image. So now if I run kubectl, apply -f deploy.yaml. So kubectl get pods. If you can see here, these 3 pods are different. These 3 pods are different. So running pods are deleted, created a fresh pods with fresh image. This is Nginx 1.14.2. This is Nginx latest. But 3 are deleted, 3 are created. Okay. 49 seconds ago deleted, 8 seconds ago created. So there is a downtime for 40 seconds, right? Even though not recommended. So what we can do, we can update one by one instead of deleting 3 pods first and create all 3 pods again. So we have a rolling update concepts. So instead of deleting 3 pods at a time, delete one, create one, delete one, create one, delete one, create one. So these are the rolling updates. Okay, these are rolling updates. So these rolling updates are not supported by replica set.yaml, only supported by deployment.yaml. That's what in real time you are using to deploy your application, deployment.yaml only. even though if you create a deployment.yaml, background replica set will be created. The replica set only gives this information. Okay, the replica set only gives this information to maintain the replicas inside the deployment.yaml. I mean, if I create a pod, only pod will be created. If I create a replica set, replicas also will be created. I mean, number of pods will be created. If I create it through deployment.yaml, replica set will be created. Pods also created along with the replica set. But if you create through deployment, rolling strategies we can implement by using deployment.yaml. Those rolling strategies, we can add some concepts here. I will show you here. Recreate and whatever rolling updates. So if you can see the rolling updates, we need to add this block in the deployment.yaml. This block will not support for replica set.yaml. So here rolling updates are nothing but we'll discuss in a different class. 25% is nothing but if 4 pods are running, so it will update first one pod, then next pod, then next pod, the next pod, like that only. I mean 25% first pod will be executed, next one more pod, next one more pod, next one more pod. For example, here replicas are 8. If you are giving 25%, 2 pods will be at a time update, 2 pods will be deleted at a time instead of 4 in one time. So this block will support only deployment.yaml, not replicas.yaml. So if you are using deployment.yaml file to deploy your application, we will get more benefits. So finally, we can use only deployment.yaml, not replicas.yaml, not pod.yaml. So these are the worker node components. So if you want to give access this pod, deployment.yaml, whatever this pod to public, we need to create a service block. Okay. And so we'll discuss tomorrow the service block. If I go for PPT, you will get a knowledge now. Let me show you. Yeah, see. Create a pod.yaml, pod will be created. Create a replica set, multiple pods will be created. Self-healing concept we can enable, scaling we can increase, decrease pods. So create a deployment.yaml, replica set will be created, pods also created, but advantage is rolling updates and rollbacks will get more advantages if you deploy application through deployment.yaml instead of replica set and pod. So clear till here? Are any questions?
It's
Clear.
clear, Vira. Clear,
Okay.
Vira.
Yeah. Okay. Okay, so let me finish service block also. We have 15 minutes time, right? So that you can practice. The very important thing is here. Service. So we have a 3 type of services: cluster IP, load balancer, node port. Okay. Kubernetes service. Okay, Kubernetes service. So, okay, you are creating a pods, but how to give access? So this is worker node. Inside the worker nodes. So maybe this is cluster, you can understand. So we have a 2 worker nodes. So inside pods are running. node 1, node 2, cluster. So now Kubernetes service used to communicate internal and external access. So Kubernetes service is used to communicate internal and external access. For example, this pod has to be access this pod. This is internal communication. This pod has to access public. This is external communication. No communication. So this is user or public. So user has to access this pod or internal access or external access by using service only. So we have a 3 type of services: cluster IP, node port, load balance. Okay, cluster IP, node port, load balancer. So cluster IP is used to internal communication. So node port is used to external communications. And load balancer also used to external communication. But always recommended load balancer only, so that we are no need to enable publish our node port or node IPs and all. So load balancer will give a secure communication access. So service, Kubernetes service gives 3 type of services: cluster IP, node port, load balancer. So you can use any 2 of the services here to give external access, node port or load balancer. But cluster IP is for internal communications. Okay, this cluster IP is used to use for this internal communication. So for internal communication, we have to give cluster IP. So this is node port or load balancer. For external communication. Okay, this is the service concept of Kubernetes. So we'll discuss tomorrow the practical, how to enable pods to public access. And okay, if I say no, me confuse. So till here, just practice. Okay, take this. Okay, I will create a one repository for you to push these changes into there. You can practice these many things, work on our components for today. Okay, you can practice here only. I will share into WhatsApp. Okay, clear? Let me share this to you. Link nodes. Yeah.
Veera, this is not related to this one, but we are having like specific nodes for separate applications, right? For Tomcat also we use 8080 before changing it, and for Jenkins also we are using the same. If those 2 are in a different nodes, can we access them like with the same port, 8080?
I mean, so here Tomcat default port number is 8080, right?
Yes.
So we can enable only 8080 is a container port. So same application, if it is run on your node, so what we can, same Tomcat application, it's not possible to run in the same node. Okay, what we can do here, we can give your different port number. I mean, no, see, Docker, how we ran local port number and target port number. Target port number always same, but local host port number we can change on the node. I mean, so same node you can run Nginx containers, 10 Nginx containers. You can give 10 Nginx containers access for 10 different port numbers, local host port numbers. But all 10 applications running on different, I mean, default target port only, but access through different port number. If you want to access Nginx 1, port number is different. Nginx 2, port number is different. Nginx 3, port number is different. So respect to port number, we have to enable required port number for local node access point of view, but not the application, the actual application runs on same port number, but we are giving access through different port number. So there is no any conflicts. Clear?
Okay.
Okay. Okay. Any questions?
No questions, Veera.
Okay. Okay, then, so we can wind up this session. Thank you so much. Bye-bye.
Yeah, thank you.